Moving on to Unit 6, this is all about graphs of sine and cosine and modeling using sinusoidal functions. So this first section, 6.1, is just simply sine and cosine graphs. Now it is the most important section. We talk about secant, cosecant, tangent, and cotangent in the next section. We talk about inverse trig, and then we talk about modeling. But being able to graph sine and cosine is a key skill for when you go on to calculus if you choose to go that route. So our objectives: determining amplitude, period, phase shift, and vertical shift of sine and cosine, graph different variations, write a function. All right, a periodic function is a function for which a specific horizontal shift p results in a function equal to the original function. Guys, all this means is that this graph repeats. Okay, like if you were to shift the graph over a little bit, it's going to be the exact same as it was at the beginning. You see no difference. So basically the period of a function, let's highlight that. The period of a function is the horizontal distance it takes for the graph to start repeating. And we're going to start with graphing sine. All right, we're going to complete this table using the values for sine, but we're going to use the decimals. It's a little easier to graph that way. So sine of 0 is 0, because that's the y-coordinate. For pi over 4, that's root 2 over 2. As soon as my calculator works. So that's going to be 0.7. For pi over 2, the y value is 1. For 3 pi over 4, that's going to be 0.7 again, because sine is positive in quadrant 2. Pi is back to 0. 5 pi over 4 is negative 0.7, because it's quadrant 3. 3 pi over 2 is negative 1. 7 pi over 4 is negative 0.7. And back to 2 pi is 0. All right, so if we graph these, 0, 0. For pi over 4 is about 0.7, so it's like right there. Pi over 2 is 1. 3 pi over 4. Pi. 5 pi over 4. 3 pi over 2. 7 pi over 4. And 2 pi. So these graphs repeat on the other side. Okay, remember sine is odd, so sine of pi over 2 would be the opposite of sine of negative pi over 2. So if sine of pi over 2 is 1, then sine of negative pi over 2 is negative 1. Okay, and then we'll go back to negative pi. I'm just doing the pi over 2's. And then sine 3 pi over 2, that's going to be 1. And back to 2 pi. And so you can see that this piece, if I shifted it over, it's going to be the exact same as that piece. All right, domain. So my domain is all the x's from left to right. So you can see that the domain is all real numbers, negative infinity to positive infinity. There's not a single angle that you can plug in where sine is going to be undefined. Okay. X-intercepts, not particularly worried about the x-intercepts. Period is 2 pi, because that's how long it takes from distance from here to here. That's how long it takes for the graph to start repeating again. So this distance, 2 pi, is the same here as well. I already talked about this. The graph is symmetric to the origin and is therefore odd. So sine negative x equals negative sine of positive x. Graph of cosine. So cosine is the x-coordinate. Cosine 0 is 1. Cosine pi over 4 is root 2 over 2, which was 0.7. Cosine pi over 2 is 0. 3 pi over 4, cosine is negative in quadrant 2, so that's negative 0.7. Pi is negative 1. 5 pi over 4, that's quadrant 3, so it's still negative. This is 0. 7 pi over 4 is quadrant 4, so it's positive. And we're back to 1. So 0, 1. 0.7. Oh, that should be up here. Wait, pi over 2. And then it repeats. Cosine is even, so cosine of pi is going to be the same as cosine of negative pi. Cosine of pi over 2 is going to be the same as cosine of negative pi over 2. So that's 0, negative 1, and then 3 pi over 2 would be back to 0, and then 2 pi would be back to 1. For whatever reason, I have a hard time sketching this one, even though it's literally the same thing as pi, or sine. That's fine. Domain, all your x's from left to right, just like sine. And you can see there's not a single angle I can plug in where cosine will be undefined. So domain is all real numbers, negative infinity to positive infinity. Don't particularly care about x-intercepts. X-intercepts don't mean a whole lot when you shift the graph up and down. Period is 2 pi. It's the parent function. So that means the distance from here to here when the graph starts repeating, this distance is 2 pi. Well, it's the same over here. That distance is 2 pi. All right, so before we get into the graphing part of it, like actually transforming our parent functions, let's go back and talk about transforming a quadratic function. The dotted line you see right here, this is the parent function. This is f of x equals x squared. So it's the parent. All quadratic graphs come from messing around with that graph. Okay, so let's talk about what transformations were done to get from the original, the parent, to our new graph. And the first thing I see is that it's negative. This graph has been reflected. This means it's upside down. Okay, that 2. Okay, it's a vertical stretch. Or vertical dilation or something, however you want to call it. Minus 5. So here's the deal with the minus 5. Inside your parentheses is opposite. Okay, it says minus 5, so we normally think of subtraction as left. Well, it's inside parentheses. We're going to the right. And I can see that. This vertex right here, that's the original vertex, is now right 5 units. So 1, 2, 3, 4, 5. You can see that vertex. 5 units. And then our plus 4, that's going to be the same. You get what you get. It is what it is. Plus 4 is up 4 units. And again, I can see that change from the vertex. Our original vertex is at 0, 0. I went right 5, up 4. Now I'm at 5, 4. All right, so all these transformations are the same for sine and cosine. All right, we have different names for them, but still the same idea. So the A in both of these represents your amplitude. That's what we would call the vertical stretch. Okay, the B, not part of that formula, sort of, but that B helps find the period of the function. Okay, the period is 2 pi divided by the B. Okay, the C here. All right, that worked just like our minus 5 right here, which was a horizontal shift. So we call that a phase shift. And then our plus D, that works just like our plus 4 right here. It's the vertical shift. it shifts what we call the midline, and we'll talk about that here in a second. So the graphs, parent functions of sine and cosine are very nearly identical. A's, B's, C's, and D's. Amplitude, finding the period, phase shift, vertical shift. All right, starting with determining amplitude. So amplitude is a vertical stretch. Its absolute value represents the amplitude. The amplitude of the function is half of the difference between the minimum and maximum values. So it's max minus min divided by 2. It describes the height of the graph above and the depth below a horizontal line passing through the middle of the graph. So this understood middle of the graph is called your midline. If the absolute value of A is greater than 1, it's a stretch. It's less than 1, but not 0. It's compression. A is negative. It's been reflected. All right, so we're going to match each graph with its function. Okay, I don't like this definition here that they give you. The amplitude is the height of the wave. Which is what, let's see, use that. When it's describing the height of the graph above and below understood midline, that's the height of the wave. All right, so for example, one here, we're going to match each one of these graphs with one of these pictures. Okay, so A goes with red. I know you can't really see this on your graph, but A goes with red, B goes with blue, and C goes with green. All right, so in our first graph here, y equals sine x, the amplitude is an understood 1. So the distance from midline is 1 unit. All right, well, the midline is the same for all 3 of these graphs. It's y equals 0. So I want the one that has a wavelength, a wave height of 1 unit. That's not 1 unit. That one is. So this is B. On our second graph, 2. So from the midline, two units. And I can see that coming from this graph that it's going to be this A, because that distance from our midline to the top of the wave is 2 units. And by process of elimination, we know this one's going to be C. And I've got an amplitude of 1/2. So from the midline is 1/2 a unit, which I can see on this graph. Here's my midline. That's 1/2 a unit. Midline, 1/2 a unit. So let's determine the amplitude of both of these functions. Remember, the amplitude is the absolute value of that vertical dilation. So my amplitude in part A is 5/3. And my amplitude in part B, be the absolute value, it's just going to be the 2. Notice that I did not highlight the negative because it's the absolute value of that. Okay, so we talked about amplitude, which is vertical stretch. Next is the midline, and you heard me talk about the midline for amplitude. So the local maxima, okay, local extrema, so mins and maxes, will be a distance of A units above the vertical midline of a graph, which is the line, so it's a line, y equals D. All right, now to find that D function, that D, it is the average of the minimum and maximum values, which means you're adding the max and the min and dividing by 2. In the graph of A up here, all right, in the graph of A, since D is 2, -2, right here, that means it's been shifted down 2 units. So their midline, original midline is up here at 0. Well, now it's here. For B, I don't have anything out here. Okay, which means D is 0. So The midline is the x-axis and will remain as y equals 0. Let's just say determine the midline. You're doing great. Okay, so determine the midline of our functions. All right, it's the number that's floating around on the outside all by itself. Our midline is y equals -4, which means it's been shifted down 4 units. For b, again, it's the number floating around by itself. Our midline is y equals 1, which means we've been shifted up 1 unit. All right, so our determining the period, this is what's called the horizontal stretch. Okay, this is how long it takes the graph to start repeating itself. All right, without any horizontal stretches or compressions, the parent function has a period of 2 pi. So to find the actual period of any other graph besides the parent function, we divide 2 pi by the b. Keyword is when it's factored out of the argument. Okay, so the period, 2 pi divided by b. So we're going to match each of these 3 functions with its graph over here. So red A, green blue, or green, try that again, green is B, and blue is C. Okay, so our first one is the actual parent function. This has an understood B of 1. So if I do the period, 2 pi divided by 1, that period is 2 pi. Okay, so from start to stop, this graph takes 2 pi units. So this one, that's pi units. Blue, that one's our 2 pi. So this one is C. Sine 2x, that 2 is the B. It should come up here. B equals 1. B equals 2. So the period, 2 pi divided by 2. This means it takes pi units for the graph to start repeating. I already know it's not C. That was the blue one. All right, so if we look at the red, so from start to stop, that distance, that's pi units. So the red one, A, is the function with a period of pi. So by process of elimination, I know that sine 1/2 x is going to be B. But here's the B. So then the period is 2 pi divided by that B. So when you divide by a fraction, you multiply by a reciprocal, so it's 2. So it takes 4 pi units. It's horizontally stretched. It takes longer for it to happen. And I can see that happening on this picture because I only have half of the graph, and that took me to 2 pi. All right, determine the period. Now, the B has to be factored out of the argument. So when I say an argument, the argument is the stuff inside of the parentheses. So that means I need to get this pi over 6 out. So I'm going to divide by it. And really, that doesn't change a whole lot on this one because there's nothing else inside those parentheses. So the B is pi over 6. So the period, 2 pi divided by pi over 6, multiply by the reciprocal. In this case, your pi cancels. And I have 2 times 6 left, which is 12. Over on B, I have cosine x over 3. That's really cosine of 1/3 x. Okay, when I'm dividing something by 3, multiply by the reciprocal, that's 1/3 of x. And then I'm going to factor that 1/3 out. which again doesn't really affect a whole lot on here because I don't have anything in the parentheses other than the 1/3 x. So the b is 1/3, period, 2 pi divided by 1/3. So this is 2 pi times the reciprocal. Which is 6 pi. Right, determining the phase shift. So it's a horizontal shift, so shifting it left or right. The phase shift is the horizontal displacement of the parent function of sine or cosine. It can be found by locating the value of c, and here's the key. After factoring out the b. All right, well, the b is going to be the coefficient of x. Okay, so same thing, we're going to match each of these functions, match all three of these with one of its graphs. There's literally no difference between any of these graphs other than where it started. Okay, I can't see where green started. Blue starts at 0, red starts at pi over 4. Okay, sine starts here in the middle. All right, so sine x, I don't have anything inside the parentheses. The b is 1, so this has no phase shift. Which means your c is 0. All right, that means I started here on the origin. So b is my graph. For our second function, all right, my b is 1, so I don't have anything to factor out. And remember, inside the parentheses is opposite, so the c is really a positive pi over 4. So my graph starts at positive pi over 4, and I see that happening here, which is A. So by elimination, C would be this last one. Again, the B is 1, so I don't have anything to factor out. Inside the parentheses is opposite, so the C is negative pi over 4, which means it was shifted left. This one was right. And this one is left. Which that's the one where we can't see the start. So the start would be like over here. What is the phase shift of each sinusoidal function? Before I go too much further on this one, sinusoidal just means it repeats. It's a wave function, so cosine is considered a sinusoidal function. Okay, just so we know that. All right, so I have f of x equals -2 sine x minus pi over 6 minus 2. The first thing I want to see is what the b is, if I need to factor it out. Well, the b here is 1, so there's nothing to factor out. All right, so that's my c, opposite. So positive pi over 6, which means we've gone to the right pi over 6 units. All right, now we haven't seen one where you have to factor out. That shows up on B. So I want you to start this one. All right, I do have a B, it's 3. All right, so we're gonna factor that 3 out. And when we factor it out, that means we've divided. I've divided this by 3, which makes it an x, but that means I also have to divide this one by 3. Dividing by 3 is the same as multiplying by the reciprocal, so that's 1/3 pi over 15. Now I can see the c. I highlighted it. Positive pi over 15, so negative. Opposite, which means we've gone left pi over 15. All right, so we had to factor out that 3 right here, and then adjust by factoring that out. Okay, now doing it all together. All right, it's a really good synopsis. A is amplitude, B is period, C is phase shift, D is vertical shift. Remember that B has to be factored out. C is after you factor out the B, and so on. So we're going to identify all the transformations. Okay, so for A, I can see that the amplitude is 1/2. That's easy. Okay, I'm going to go ahead and go down here to reflection. This 1/2 is not negative. We have no reflection. I have space here. Okay, the period. Okay, I need to factor out the B. All right, well, just like I showed you a couple seconds ago, x over 3 is really 1/3 x. I've got to factor it out. All right, that 1/3 needs to be on the outside. So dividing by 1/3, divide by 1/3. So pi over 3. Now when divide by 1/3, it's the same as multiplying by 3. That's 3 over 1. So that's pi. Okay, so the b's here on the outside now. So the period. Two pi divided by the b. So that's 6 pi. I can see the phase shift now. I want to think opposite. There's a positive pi. So we've gone right pi units. And the vertical shift is usually floating around out here. I don't have a vertical shift, so that means that the midline is at y equals 0. Okay, amplitude. I see that pretty easily. Amplitude is 3. It's not negative, so I have no reflection. The period, I need to factor that 2 out. On this one, it's not going to really change anything because I didn't have anything inside the parentheses with that x. So the period, 2 pi divided by the b. So that's the b. So the period is pi. I don't have anything on the inside, so the c is 0. So I don't have a phase shift. I have a +1. So it means my vertical shift is y equals 1. It means we've gone up 1 unit. All right, amplitude 1, it's understood. It's not negative, so no reflection. Period. Okay, I'm not going to show the factoring out. I don't need to because there's nothing inside the parentheses here besides that pi x. So if I'm going to find the period, is 2 pi divided by the b. That's that pi. So the period is 2. Okay, since there wasn't anything else in the parentheses, that means the c is 0. Which means I don't have a phase shift. D is 3. So that means I have a vertical shift. Midline is at y equals 3, so that's up 3 units. Okay, this last one, amplitude is 2. Amplitude is the absolute value of whatever's there. So amplitude is positive 2. It is negative, so there is a reflection. Okay, period. I do have something going on the inside here. But if we look in front of that x, that is a 1. So that means your b is 1. So the period, 2 pi divided by 1 is 2 pi, just like your parent function. Your C, okay, that says plus 3 pi over 4, so C is negative 3 pi over 4, so that means we've gone left 3 pi over 4. I don't have anything out here, so it means the D is 0, which means the vertical shift is none. It's at y equals 0. So let's put these things on a graph. So all of these graphs right here, you don't have anything labeled, so you can scale it however you want to. Okay, so you can scale each one of these by 1s, by pi's, pi over 2s, whatever. All right. All right, so I need you guys to pay attention to this. All right, so the first thing we're gonna do is find the key parts, amplitude. Do it over here. Amplitude is 3. Okay, I can see the B is pi over 2, which means the period is 2 pi divided by pi over 2, which is 2 pi times 2 over pi, so that's 4. I have a phase shift, left 3. And I have a vertical shift, down 2. All right, so I'm gonna start with that midline. The D is negative 2, so I'm just gonna do these by 1s. So negative 2 is here, so I'm just gonna draw a dotted line. Amplitude is 3, which means I can go high as 1 and as low as negative 5. Okay, now, when you graph, okay, you graph as if you don't have a phase shift yet. All of these points start at 0. These are called your 5 key points. And start at 0. Okay, that means I have 4 more key points. All right, so to get the distance between each x coordinate, you take the period, so take the period divided by 4. And it's always 4 because there are 4 numbers left, because we always start with 0. So 4 divided by 4 is 1. So it means the distance between each x coordinate, each key point, is 1 unit. So 1 more than 0 is 1, 1 more than that is 2, 1 more than that is 3, and for our last one, 4. Your 5th number should match the period. Okay, but we did have a phase shift. Okay, and that phase shift says left 3, so I'm going to subtract 3 from each of these. All right, now to actually put this thing on a graph, okay? Sine has a very clear pattern. If we go back and look, all the way at the beginning, we're gonna use, green, 0, pi over 2, pi, 3 pi over 2, 2 pi. These are our 5 key points, 1, 2, 3, 4, 5. So sine starts at a mid. So it starts on a midline. I can see that because the midline is 0. Our next key point at pi over 2 is a maximum, so it is a high point. Back to pi, or 0, that's a mid. 3 pi over 2 is down at -1, that is a low. 2 pi is back to 0. You're back to mid. This pattern is the same for all sine functions. So 0 starts mid. -2 is a high. -1 is back to mid. 0 is to low. And 1 is back to mid. So it means at -3. Okay, I haven't scaled this yet. It doesn't really matter to me how you want to scale it since we're already doing by ones. I'll just do by ones. I'm only going to label by 2s because I don't want to take up too much space. But it's really scaled by 1s. So at -3, which is here, we're on the midline. Okay, -2, we're on the high, which is the highest it can go. -1 is back to mid, so we're here. 0 is back to low. And 1 is back to mid. And this pattern repeats. 1 was mid, 2 would be high. No, we'll use a different color. Three would be mid. 4 would be low. 5 would be mid. 6 would be high, and I can go the other direction. -4 would be low. -5 would be back to mid. -6 would be high. -7 would be back to mid, and so on. See how that graph repeats over and over again. It does take some getting used to when you do this on Lumen. Just going to give you some warning on that. Okay, I didn't even see that I did this. Amplitude was 3. Period was 4. Phase shift was left 3. Vertical shift is -2, and no reflection. Okay. I have y equals -2 cosine 2 theta plus pi over 2 plus 1. I can see that the amplitude is 2, and there is a reflection. And I know that because it's negative. So let's get the period, and we need to do that by factoring out this 2. So pi over 2, oops, divided by 2, so it's plus, or it's times 1/2, so this would be pi over 4. So the b is 2. So period would be 2 pi divided by 2, which is pi. The phase shift, okay, plus pi over 4, so this would be opposite. Vertical shift up 1, and then of course we had the reflection. Okay, so all key points start at 0. To get the distance between the x's, take the period, divide by 4. Pi over 4 is already reduced. All right, so that means I'm going to increase by pi over 4 from 0. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And reduce if we need to. This fifth one should match the period. Hey, I got my 5 key points, but I do have a phase shift. Left pi over 4. So I can subtract pi over 4. Remember, with fractions, you have to have a common denominator. So pi over 2 was really 2 pi over 4. So 2 pi over 4 minus pi over 4 is 1 pi over 4. Again, common denominator, pi was 4 pi over 4. So 4 pi over 4 minus pi over 4 is 3 pi over 4. All right, so this is cosine. So let's go back to cosine. And we're going to do key points. 0, pi over 2, pi, 3 pi over 2, 2 pi. This time, for cosine, the very first ordered pair, 0, 1, starts high. Then it goes to the midline. You can see that right there. Goes to -1, that's low. Goes back to 0, that's a mid. Goes back to 1, that's a high. So sine, mid, high, mid, low, mid. Cosine, high, mid, low, mid, high. Awesome. So in theory, this one should start high. Mid, low, mid, high. Okay, problem is there's a reflection. So the reflection changes, I don't know what color, your highs and lows. So because there's a negative, this high becomes a low, low becomes a high, high becomes a low. Okay, so vertical shift was 1. So let's just do by ones. Amplitude is 2, so it goes as high as 3 and as low as -1. I'm gonna scale these. I don't want them super close together. It's pi over 4, but skip every other one. So 2 pi over 4, that'd be pi over 2. So it's 1, 2, 3, 4. This would be 5 pi over 4. 6 pi over 4. Okay, so negative pi over 4 starts low. Zero, mid. Pi over 4, high. Pi over 2, mid. 3 pi over 4, low. And these start repeating. Okay, so at pi, I'd be back at mid. 5 pi over 4, I would be at high. 3 pi over 2, I'd be back to mid. Okay, on the left, pi over 2 would be back to mid. 3 pi over 4 would be high. And pi would be mid. 1/2 cosine pi over 4x plus 2. I can see the amplitude is 1/2. No reflection. All right, so it's a period phase shift. Oh, no vertical shift, so y equals 0. So I'm here on the y-axis. I'm going to factor out a pi over 4. When I factor that out, that cancels, which is why I have an x. So pi over 2 times 4 over pi. 2 goes into 4 twice. Okay, so period would be 2 pi divided by the b. So that would be 2 pi times 4 over pi. That's 8. Phase shift, I got a b of plus 2, so it'd be minus 2. No vertical shift. Okay, so then our key points always start at 0. I'm going to take our distance between x's, take the period, divide by 4. Okay, so that means the distance between each x is 2 units. So up 2 from 0, up 2 from that, up 2 from that, up 2 from that. Fifth number should match the period. Okay, so now we're going to apply the phase shift, minus 2. All right, so 1/2. So I'm going to scale this by half units. So this is 1 up here, which means half is right there. -1 would be down here, so half a unit. You can scale it however you want to. I just want you to be able to see what's going on. I'll just do by 2s. 2, 4, 6, 8. Okay, so this is cosine. Cosine is high, mid, low, mid, high. No reflection, so we get what we get. So at -2, we start high. Zero or mid. 2 we're low. 4 we're mid. 6 we're back to high. And I can continue that pattern. 8 would be back to mid. 10 would be low. 12 would be back to mid. -4 would be mid. -6 would be low. -8 would be back to mid. -10 would be high. -12 would be back to mid. Just repeating the pattern. Okay, now writing equations. So I've given you a whole bunch of like tips here, okay? So helping things to find A, D, B, and then C. All right, so we have A, which is 1/2 max minus min. You can also count, not that hard. Midline is 1/2 max plus min. All right, so to get to the B, we need the period. All All right, so the distance, you can find the period in 3 ways. Low to low, high to high, 3 mids. These two, cosine, this one, sine. Okay, phase shift for sine, so finding the C. Ideally, you want a mid followed immediately by a high. If you have a mid followed by a low, your amplitude is negative. For cosine, you want to look for highs. If you look for a low, the amplitude is negative. Okay, so we're determining a cosine function. Sometimes he'll just say, right, determine the equation for the line. Mine's specific to cosine. All right, so honestly, the first thing I'm going to do is I'm going to figure out the value of the minimum, which is -2, and the maximum, which is 6. Okay, so that's going to help me find amplitude. Amplitude is 1/2 max minus min, or just max minus min divided by 2. So max minus min divided by 2. Okay, find the D next. Max plus min divided by 2. And I can see that midline pretty easily right here. And I can see that the distance from the peak, the maximum of a wave and the minimum of a wave is 4 units. Okay, I can see all that. So the next thing I gotta figure out was what the B is. In order for me to find the B, I need the period. All right, so this is cosine. I'm gonna find the distance between 2 highs. So I have a high here, and I've got another high there. I want this distance. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. So the period is 14, which means the B, 2 pi divided by 14, so that's pi over 7. Okay, last but not least, I need a C. I don't care what you use. I have 2 highs right here, 1 there, and I also have a low. It does not matter. It really doesn't. I'm going to choose a high. I'm going to say 7. All right, so function. And since this was a high, amplitude is positive. Cosine, B, use your parentheses, x minus C plus D. Okay, if I had said that C was 0, okay, if C was 0, that's a low. And by the way, the C is the location, it's not the value. So the low is located at 0. High is located at 7. If I had said the C was 0, a low point, what changes is that the amplitude is now negative because you started low instead of high. You also don't have anything inside your parentheses because the C was 0. But everything else would stay the same. All right, this one just says determine the equation, so it's sine or cosine, it does not matter. So, since I can clearly see the midline and the amplitude, I'm not gonna mess with finding the min and the max. I can see that the amplitude is 2. I can see that the midline, the D, is 0. Period, I'm gonna count high to high. So this distance here, okay, that's 4 units. Okay, I do want to show you the other ones. If I do low to low, that's also 4 units. And if I do 3 mids, 1, 2, 3, this distance, 4 units. So doing any of those 3, you're going to get the period. Which means the B, 2 pi divided by the period. B is pi over 2. All right, now I'm going to do sine on this one. So it means I need a midpoint. So I can see I have lots of midpoints. I can choose any one of them. Easiest one to choose is that one because its location is a 0. All right, but then I want to look for the point directly after that. The point directly after that is a high, A is positive. If the point directly after that is a low, A is negative. So since it's mid-high, A is going to stay positive. So 2, this time I'm doing sine, B, X, and that's really all I have to do because the midline was 0. If I had said that the C was 2, so that is a mid followed immediately by a low, that changes my function. Since it's mid-low, negative. And it'd be X minus 2. Okay, doesn't change much else, but there we go.